These are your 12-3B notes on reference triangles. So it's a pretty easy day, but I didn't want to combine today's information with the next step. So the next step is to do all the exact values, all the exact trig values. So today we're just going to talk about reference triangles. And a reference triangle, or reference angle, is the theta prime that I mentioned earlier. So it's the acute angle formed by the terminal side of theta and the x-axis. So it just gives it a formal name. So in yesterday's work, we worked with a point. We never really had degrees for angle theta. Even though we found all the trig values of angle theta, we really didn't know an angle measure that related to it. We just followed that point that they gave us and where it put the angle. So today, we're going to take it a step further. They're going to actually give us the angle measurement for theta, and then we're going to give a new angle measurement for theta prime, and it should be the acute angle inside the reference triangle. So the reference angle, it depends on where the terminal side of your angle lies, what you do to find theta prime. So in quadrant 1, if you want to draw these pictures, and you can pause at any time here, theta prime is equivalent to theta because it's an acute angle in the first quadrant. So that reference angle, they're the same thing. There's really no adjustment that you need to do there. They are the exact same values. If it's an angle in quadrant 2, now it's an angle that's between 90 and 180 degrees. Theta prime then is the difference in between those. And so to figure out that amount, you subtract theta from 180, and that will give you theta prime. Now, if you're working with radians, you need to show that work with radians, and so you would subtract the radian measure from pi, since 180 and pi are the same thing. So you're just trying to figure out that leftover amount from 180. If you're in the third quadrant, you're looking at just the little tiny theta prime is the little angle there beyond 180 degrees. So theta is larger than 180 degrees. So you subtract 180 degrees from theta. And again, just down below, it shows in parentheses how you would do that if it was radians. That's the only difference there. And in quadrant 4 now, we're not really closer to 180. We're actually closer to 360. And so we're not going to use 180 in our calculations. We will subtract theta from 360 to get theta prime. It's really kind of a common sense thing. You're looking for that leftover amount with 180 or 360. Sometimes it's 180 take away theta, and other times it's theta take away 180. Now, the way that these are written, these rules are written for positive angles. When you get into negative angles, they kind of flip-flop their rules. Like 2 and 3 will switch, and 1 and 4 will switch because it depends on where you're located. So use a little common sense. You're trying to come up with that acute value formed with the x-axis. So direction can change these rules a little bit. So I have 4 examples here for us. Okay, now I still want the whole picture because it all leads to the next phase. So the very first thing we're going to do is draw the angle. So instead of giving us a point now, they're actually giving us degrees. So we're going to draw 300 degrees. Okay, 300 degrees is in the 4th quadrant. It's not in the middle. It's slightly less than middle. Okay, so it's going to be closer to the y-axis than it is the x-axis. So I'm going to try to be that accurate as much as I can. 315 would be right in the middle. 330 would be a little bit closer. So we're about 300, and it probably could be even a little less than this. I'm going to do my directional arrow, saying that it's a positive 300-degree angle. I'm going to label it 300 degrees. And so there's theta. Theta is 300 degrees. Now, eventually, we're going to find the sine, cosine, tangent of 300 degrees. But today, we just want to come up with the actual value of the little acute angle that we're going to use that goes along with 300 degrees. So if I draw my reference triangle, label this theta prime, and then we're going to actually do some work outside. So the picture shows me what theta prime is, And then outside of there, I'm going to describe that theta prime is equivalent to, since we're in the fourth quadrant, 360 take away 300 degrees. And so then theta prime is equal to 60 degrees. That's all I want. I want to see what calculation you were using, and then you actually show me the answer. If you just give me theta prime equals 60, it's not enough information. I want to see how you came up with that information. It's all about telling the story. And that's it. So that would be the reference angle. We would use a 60-degree angle to find any trig value involving 300. They're related. For number 2, it's in radians. So for radians, we're going to show our work in radians. And so when I have to draw 7/4 pi, I like to quickly just go off to the side and say that this would be 4/4 pi, and this would be 8/4 pi, or 2 pi. So 7/4 is almost 8/4, so it's going to be in the fourth quadrant. And since it's a fourth, it's going to be right in the middle. So right in the middle is a 45 degree. And so here's my 7/4. I'm going to draw my directional arrow. I'm going to label 7/4 pi. That's theta. Theta is 7/4 pi. And so theta prime, my new theta, is this little angle in here. And so I'm going to draw my reference triangle, finish it off, make my right triangle, and then I'm going to actually take that work out and describe what theta prime is. Since I'm dealing with radians, I need to subtract theta prime from 2 pi. Now, it's a little bit easier. You can say 2 pi, or you can say 8/4 pi, because that is 2 pi. Take away 7/4 pi, and theta prime then is equal to pi over 4. You should always get an acute angle for theta prime. So if you don't get an acute angle, you did something wrong in your calculations. You should always get a positive acute angle that belongs in quadrant 1. All right, going on to number 3, negative angles. So I have a negative 210 degree angle. If I move a negative 210, that's actually going to end up being in the second quadrant. It's not quite halfway. It's just 30 degrees or so beyond the 180. So remember, this is negative 90. This is negative 180. So this would be negative 210. Show my directional clockwise motion here. Show my label, negative 210 degrees. There's theta. Now, what I need is that little tiny acute angle formed in the corner here. Here's my reference triangle. There's theta prime, and then outside, I'm going to show the work for theta prime. Now, I need to know the difference between 210 and 180. I understand that my angle is negative, but I'm going to ignore the negative. The negative is not the size of my angle, it's the direction of my angle. So I'm going to just take the absolute value and say 210 degrees. And I'm going to subtract the 180 because I'm thinking it through. I got to get a positive acute angle. I need big minus small. So I knew I was working with 180, but I'm going to put 210 first, subtract the 180, and 210 take away 180 is 30 degrees. It's a positive acute angle in the first quadrant. And the last example is a negative radians. So we have negative 5/6 pi. And so again, I like to say then that this would be negative 6/6 pi. And all the way around clockwise would be negative 12/6 pi. I'm just writing 2 pi in terms of 6 there. And it tells me that I'm not quite 1 pi yet. So I'm actually in the third quadrant. And 6 tells me that it's a 30-degree angle. So I'm actually just under, right about here, in the third quadrant. So I didn't quite make it around halfway clockwise. So I show my directional arrow. I show my label. There's theta. I'm going to label theta prime inside here. draw my reference triangle, and then explain what theta prime's size is. Theta prime, using pi, I need, pi is bigger. So again, I'm going to ignore the negatives, and I know that 6/6 is bigger than 5/6. So I'm going to take 6/6 pi and subtract 5/6 pi from it. Therefore, theta prime is equal to 1/6 pi, or pi over 6. Now, you don't have to write pi as 6/6 pi. I like to do that because we're working with fractions, so I like to get the common denominators. Anytime you add or subtract radians, you need that common denominator. Your calculator will do it for you, though. And there you have it. So for your lesson summary, somewhere in here, I think it's a freebie, and find the reference angle for a 110-degree angle, draw a picture, and show all your work. Good luck.